Okay, so this video is for week 17, lesson 2. Okay, so I want to start this lesson by reviewing some factoring methods that you already know. All right, so like you know how to factor something that has a greatest common factor, right? These two terms both have an x in common. You pull the x out of both and you're left with 3x plus 1, right? Let's review. You know how to do this. You know how to factor a difference of squares. This becomes x plus 2 and x minus 2, right? And you know how to factor a trinomial, all right? You may have learned multiple different ways how to do it, but the answer ends up being the same. It's x plus 6 and x minus 1. So what we're going to do today in this lesson is we're going to factor expressions, but they're going to have trig functions in them. Okay, so for example, take a look at example number 1. So what I want you to do is to try to ask yourself, does this look like anything that I've seen before, right? If this wasn't sine squared x, right? If it was just something else squared, right? What if this was just like y squared minus 1? That wouldn't be quite as intimidating, right? You can factor y squared minus 1. It's y plus 1 and it's y minus 1. But we don't really have y squared, do we? We've got sine squared. So really, kind of all you have to do is replace each of those y's with a sine of x. Okay, it's kind of solving it by substitution. All right, now some of you are going to look at that and go, I don't need to do substitution. I can just factor it. And that's fine. Go right ahead. But some people are going to need to change this to not be so, like, I don't know, intimidating looking, I guess. Right? So like on this one, there's a lot of different cosines and things going on here, right? But if I rewrite this, as long as I recognize that this is something squared and this is that same thing, just not squared, this is kind of the same thing as having, I don't know, 6m squared minus m minus 2, right? You know how to factor this. It's a trinomial. It's going to end up being something, right? You need numbers that multiply to be negative 12, that add up to be negative 1, all right? And again, the way I know how to do this is to figure out the numbers that work here and divide by the leading coefficient. And if those reduce, which they both do, then I know what numbers to put in here. I know that this is going to be a 3 along with a negative 2, and that this is going to be a 2 along with a positive 1. And then I just need to sort of fill in here what the original problem had. Right now here I would be filling in m's, but that's not really the original problem, is it? The original problem has cosines in place there. All right, so you're going to factor it the way you're used to. It's just you're factoring with trig functions. Okay, so let's scoot this up and take a look at this last one. Okay, now again, this may look very, very confusing the way that it is right here. But what if I just said, no. What if this problem, instead of having sines and cosines in it, what if this was just mn plus n? If I said factor that, I don't think there's a single one of you that wouldn't say, oh, factor out the n, factor out what they have in common. Well, these two terms have a cosine in common, right? And if you started with this problem, right, and you took out the n, you'd have two terms left. You'd have m plus 1. So the question over here is, what two terms do we have left? Well, if I took out a cosine here, I'm left with sine of x. If I took out cosine out of itself, I'm left with 1. Okay? Again, just a reminder, you know how to factor. Don't let the trig functions scare you.